Alright, so we're going to do question 6.12. So in these questions, we are asked to find expressions for the marginal rate of substitution in each of the case with a different utility function. So this is basically just an exercise for you to practice how to find the marginal utility, which is just the partial derivative of a utility function. Okay. So part A, we are given a utility function as a function of b and c equal to kb times b plus kc times c. Okay. So to find the marginal rate of substitution, we know that it is the negative of the marginal utility ratio. So we would have to find the marginal utility first. Okay. So we find the marginal utility of b. It's just going to be equal to the differential of the utility function with respect to b. Okay, and so this is called the partial derivative of a utility function with respect to b. Alright, so when you differentiate a utility function, a function of two variables, b and c, with respect to one variable, which is b in this case, then we're basically treating the other variable as constant. Okay, so if you differentiate this function over here with respect to b, we are treating c as constant. Alright, so if we differentiate this kb times b with respect to b, then we get kb, which is just the constant in front of the variable. Okay, and if we differentiate this kc times c with respect to b, we are getting 0 because the whole thing over here is treated as a constant. Okay, c is being treated as a constant as well, so it just becomes 0. Alright, so we got kb. So we do a very similar thing to find the marginal utility of c, which is just the differential of a utility function with respect to c. Alright, so if we differentiate this function over here with respect to c, now kb times b, it just becomes 0 because it's just a constant. Okay, so when you differentiate a constant with respect to a variable, you are getting 0. And if we differentiate kc times c with respect to c, we get kc. And so we got kc at the end. Alright, so the marginal rate of substitution is just going to be the negative of the marginal utility ratio. So I got marginal utility of b on marginal utility of c. Okay. Now, if anyone wants to put marginal utility of c on marginal utility of b, it's totally fine. Okay, the result will be different. However, it's either way is correct. Okay, whatever you want to put on a vertical or horizontal, that is fine. Okay, so therefore, whether it's marginal utility of b first or marginal utility of c first, it doesn't matter. Okay, either way is correct. So I got negative kb and kc for this case. Okay. Now part B, you are given a utility function equal to b to the power half and c to the power half. Okay, so again we find a marginal utility of b, which is the differential of utility function with respect to b. Okay, so over here again we are treating c as constant, so a constant in front of the variable will remain the same, so c 0.5 is going to remain the same. And if we differentiate b to the power 0.5 with respect to b, you will get 0.5 in front. Okay, you take the power in front, and b to the power of 0.5 minus 1. Okay, and so that is going to give you 0.5, c 0.5, b negative 0.5. Okay, so it's very similar marginal utility of c. It's just going to be a differential of b and c with respect to c. Okay. So in this case, we're treating b as constant. So b to the power 0.5 is just going to remain the same there. And if you differentiate this c to the power 0.5, you get 0.5 times c to the power 0.5 minus 1. Okay, and that will just give you 0.5 b to the power 0.5 and c to the power negative 0.5. Okay, so therefore our marginal rate of substitution is negative of marginal utility of b on the marginal utility of c. And so that is negative 0.5, c 0.5, b negative 5, sorry, negative 0.5 divided by 0.5, b 0.5, c negative 0.5. Okay, so 0.5 and 0.5 will cancel out. C to the power 0.5 divided by c to the power negative 0.5. Now if you got a negative over here, what you do is if you move it to the numerator, you will be able to get rid of a negative sign. Okay, so it's just going to become, so c 0.5 over here remain the same. And if you move this c to the power negative 0.5 up to the numerator, it becomes c to the power 0.5. Okay, and then I got b to the power 0.5 over here, which is remain the same here. And if I move b to the power negative 0.5 down to the denominator, I will be able to get rid of a negative sign. So it's become times b to the power 0.5. Okay, now c 0.5 times c to the power 0.5 is going to become c 0.5 plus 0.5. Okay, so that's the power rule. And b again very similar, 0.5 plus 0.5. Okay, and so that will give you negative c power 1 on b. Okay, and the question telling you where possible try to express the function as a function of a ratio b on c. So what we got over here is c on b. If you want to express that as the b on c, it's just going to be 1 divided by b on c. Very straightforward. Okay. Alright, so part C, utility function is given by b to the power 0.5 plus c to the power 0.5. Okay, so again, marginal utility of b is just going to be the differential of the utility function with respect to b. Alright, so we differentiate b to the power 0.5 with respect to b, you get 0.5 b to the power negative 0.5 and plus, now c to the power 0.5, you differentiate with respect to b, you get 0 because we're treating c as constant. So if we differentiate a constant with respect to variable, we get 0. Okay, so this will give us 0.5 b to the power negative 0.5. Marginal utility of c, again, just the differential of utility with respect to c. Again, we are treating b as constant, so if you differentiate this, you get 0. Plus c to the power 0.5, you get 0.5 c to the power negative 0.5. Okay, and so marginal rate of substitution is just going to be the negative of the marginal utility ratio. So you got negative 0.5 b negative 0.5 divided by 0.5 c to negative 0.5. And so 0.5 will cancel out, you got negative. And we got b on c, everything to the power negative 0.5. Alright. Okay, so utility in part D, we are given a utility function b is 0.5 plus c is 0.5 and everything square. Okay. Alright, so again we want to find a marginal utility of b, which is just the differential of u with respect to b. Now if I want to differentiate this function with respect to b, how does that work? So basically we will, it's a little bit more complicated here, so you will have to take into account So we basically have to apply the chain rules over here. Okay, so you're treating the whole thing inside a bracket here as a function. Say I would say this is f. Okay, as a function of b and c. Alright, so the whole thing inside the bracket is f. So the rule for differentiation, applying a chain rule over here, is when you want to differentiate an f square. Okay, so you want to differentiate u with respect to b. Okay, and we know that u is just basically a function f square. Okay, so basically we want to differentiate u with respect to f, and then we multiply by differential of f with respect to b. Okay, so this is called chain rule. So we know that, so given that, okay, u is equal to f squared, because everything inside the bracket is f. Okay, so therefore the change in u given the change in f, so if we differentiate u with respect to f, then it's just basically a function f squared. So if you differentiate, that will give you 2f. Okay, and since we have f is equal to b 0.5 plus c is 0.5, so therefore the change in f with respect to b, now we just have to differentiate this function with respect to b, and that just gives you 0.5 b to the power negative 0.5, yes, and plus c, which just become 0. So that gives you 0.5 b to the power negative 0.5. Okay, so if you're applying the chain rule over here, then you get change in u given the change in b is equal to change in u given the change in f, which is 2f, times the change in f on change in b, which is 0.5 b negative 0.5. Okay, and knowing the function f, we just substitute it back into here. So f is just b 0.5 plus c 0.5, yes, this is f, times 0.5 b to the negative 0.5. Okay, so if you simplify this, 2 multiplied by a half will give you 1. So what we got is b 0.5 plus c is 0.5, everything times b to the power negative 0.5. Okay. Alright, so that's the first marginal utility. Okay, so the marginal utility of b is equal to b 0.5 plus c 0.5, everything multiplied by b to the power negative 0.5. Okay, so we do a very similar thing to find the marginal utility of c, which is just the change in u given the change in c. Again, applying a chain rule, this is just the change in u given the change in f, times the change in f given the change in c. Okay, so change in u given the change in f we already found earlier equal to 2f. Okay, and the change in, okay, from before, and the change in f given the change in c. So given that f equal to b's power half plus c's power half, if we differentiate that with respect to c, you get 0 for the first term, okay, just a constant, okay, and plus 0.5 c to the power negative 0.5, and that is 0.5 c is negative 0.5. Okay, so therefore marginal utility of c is just going to be equal to 2f times 0.5 c negative 0.5, and that, so f is b 0.5 plus c is 0.5 times 0.5, c negative 0.5. Okay, and if you simplify, it will give you so 2 times I have equal to 1, and that is just b 0.5 plus c 0.5, everything times c negative 0.5. Okay, so from here we should be able to find the marginal rate substitution, straightforward. Okay, and that is negative b 0.5 plus c 0.5, everything times c negative 0.5 divided by b 0.5 c 0.5. Sorry, it should be b. C negative 0.5. Okay, now these two terms in the brackets cancel out. So what we got left with is negative b on c, everything to the power negative 0.5. Okay. And the last case is where the utility function is equal to bc on b plus c. Okay, so over here we are going to apply the quotient rule to differentiate. Okay, so the quotient rule is when you differentiate a function of fx and gx. Okay, with respect to x, then it's equal to f dash of x gx minus fx g dash of x, and everything divided by gx squared. Okay, so that's the quotient rule. So in this case, we are just going to assign the thing on the numerator as a function. Okay, so we, as a function of b and c, so we let f equal to b times c. So the first thing equal to f function, and the denominator is equal to g function, b plus c. Okay, so basically our utility now, it just basically a ratio of the two functions f and g. So if we want to differentiate, so if we want to find a marginal utility of b, we just have to differentiate the utility function with respect to b. Okay, and over here it's basically just the differential of these ratio over here with respect to b. So if you apply the quotient rule, it's going to be equal to f dash so instead of using f dash, I will use the change in f. Okay, even the change in x. And instead of, basically they are just the same thing. Okay, it's just the differential of the function with respect to so this is g x. Okay, so it's basically just the differential of f with respect to b times g function minus f function times the differential of g with respect to b, and everything divided by g squared. Okay. Now, so the differential of f with respect to b, given that f equal to b times c, if you differentiate f with respect to b, you're treating c as a constant, okay, and that is just going to give you c. Now the differential of g with respect to b, so g function equal to b plus c. So if you differentiate that with respect to b, you get 1 and if you differentiate c with respect to b, you get 0. So 1 plus 0 equal to 1. Okay, so therefore if you substitute this value back into our formula over here for the marginal utility, then you get c times g minus f times 1, and everything divided by g squared. Okay, and knowing the value of the function g and f, we just have to substitute back into here. So g is equal to b plus c minus 1 times f, and f is just b times c. Okay, and everything divided by g squared, which is b plus c, everything squared. Alright, so that is our marginal utility of b. It's very similar. We're just going to find the marginal utility of c, which is just going to be the change in u given the change in c, and that is just going to be the change in, again, we're applying the quotient rule where we differentiate f with respect to c and we multiply by the g function. Okay, minus f, okay, and the differential of g function with respect to c, okay, and everything divided by g function square. Okay, so again, differential of f with respect to c. So we got the f function is here, which is b times c, and if you differentiate that with respect to c, you will get b. Okay, and the differential of g function with respect to c is just going to be, so g function is b plus c. So if you differentiate that with respect to c, now if you differentiate b with respect to c, you get 0. If you differentiate c with respect to c, you get 1. So that will just give you 1. Okay, and so therefore marginal utility of c is just going to be equal to b times function g minus function f times 1, and everything divided by function g square. Okay, so knowing function f and g, which is substitute out into here, I get b. Now g is b plus c minus, and f is b times c, everything divided by b plus c square. Okay, so I got two marginal utilities. I should be able to find a marginal rate of substitution now, which is just going to be the negative of the marginal utility of b divided by the marginal utility of c. Okay, so I got negative c b plus c minus bc, everything divided by b plus c square. Okay, and the whole stuff divided by b plus c minus b times c, everything divided by b plus c square. Okay, so I got negative over here. Now the denominator b plus c square will cancel out, will cancel each other. Okay, so what I'm left with is negative c b plus c minus bc, everything divided by b plus c minus bc. Okay, so that's my marginal rate of substitution.